Okay, in this video we're going to take a look at yet another method. This is going to be the last of our methods of solving systems of equations, and the system that we're going to be looking at actually is going to be a 2 by 2 using this method, not a 3 by 3. Okay, so first let's talk about the determinant of a matrix. Okay, now it turns out that if a matrix has the same number of rows and columns, A, B, C, D here for example, that has 2 rows and 2 columns, we call this a square matrix. Remember, matrix was a rectangular array. Well, if the rows and columns are the same, the rectangle turns into square. So this is called a square matrix. An attribute or characteristic of every square matrix, and here's a case of, let's say, of a 3 by 3 square matrix. It's gonna look like the following. Let me get this going here. Okay, so this is what it's gonna be. Let's say I have 1, -1, 2, 3, 0, 5, 7, half, 2/3, just so they're numbers. Okay, there you go. This is an example of a 3 by 3 square matrix. Okay, that's what that is. Now, it turns out that for every square matrix, there is an attribute of the matrix that exists and we can actually find, and that attribute is determinant. Okay, so how is this determinant defined? The determinant of a 2 by 2 matrix, so I'm going to write it like this. DET for determinant, A means matrix A. In the book they use what seems to be absolute value, but that's actually a poor choice of notation, because it does look like an absolute value, but it really is not an absolute value, but that's what it is. And of course A here is the name of the matrix. Okay, so and this is how we write it. If matrix is 2 by 2, it's A, B, C, D. Its determinant actually is found by multiplying AD and then subtracting product of BC. So in other words, we're going to multiply the diagonal elements AD together, subtract the off diagonal elements B and C from it, the product. Okay, so this is how it's done. It's pretty easy for a 2 by 2 if we can remember this formula. And of course you don't have to memorize it, you just have access to it. So just to do an example here, let's say in the book I'm going to take a look at an exercise. There's not too many of these in your book, by the way. Let's say I want to find the determinant in exercise number 8 is the one I'm looking at. It's 3, 2, and then we have 2, -3 here, and I want to find that determinant. Okay, so the determinant is going to equal to the AD, that means 3 times -3 minus 2 by 2. That's all you got to do. That's -3 minus 4, or -13. What does that -13 tell me? In and of itself, it really doesn't mean anything. It's just something we can do with square matrices. Now, we use this in conjunction with other determinants in order to solve system, interestingly enough. So that's how you have a formula for this. Now, the book gives you a formula to find the determinant of a 3 by 3 matrix. But again, this is something we're not going to be doing later on. So I'm just going to give you a shortcut in finding a 3 by 3 determinant. So here is an example. Let's say I want to find the determinant of 210, 401, -2, 2, and 3. Okay, now I'm showing you the shortcut. Okay, so again, don't worry about the formula, that's in the book. So this shortcut calls for the following. We're going to repeat the first 2 columns of this matrix. You see that? I replicated it, I copied them. And then we're going to do this. We're going to multiply diagonal elements in this direction. And there you go. So we're going to multiply those together. 2 times 0 times 3 would be 0. 4 times 2 times 0 is 0. Negative 2 by 1 times 1 is negative 2. So those are the products. So again, we did products going in diagonal in this direction. 2, 0, 3 gives me 0. 4, 2, 0 gives me 0. Negative 2, 1, 1, the product, negative 2. Now once we have that, next step, we're going to add them. Add, and we get negative 2. So the determinant is negative 2. But wait, that's not done. Minus. This negative here would be equivalent to negative that's up there in the 2 by 2 case. Okay. Now, what are we going to subtract here? Well, we're going to subtract now products going in this direction. Right? The other direction. Those products. So I'm going to do 4 times 1, 4 by 1 by 3, 2, 2, 1, negative 2, 0, 0. Those are the products that we're going to do. Okay. So that makes it 12. 2, 2, 1 is 4. Yeah, 2 by 2, 4 times 1 is 4. And negative 2, 0, 0, the product is 0. And then we're going to add them. They add to 16. And there is the answer to the determinant, negative 18. So there, that's how you do it quickly if you need to find the 3 by 3 determinant. But again, we're just going to solve system of 2 by 2s using Cramer's method. And let's actually do this. Let's solve a system. Now, using Cramer's method, first I'm going to write the system. So this is exercise number 18. The system is 3x negative 4y equals 6. And then 5x plus 9y is equal to 10. Okay, and we want to solve by Cramer's method using determinant. Now here's how this method works, named after Cramer, who actually proposed it. What we need to do is we need to do the following. We need to write D. D is the determinant of the matrix of only coefficients. And there you go. Now these coefficients are, you see that 3, 5, negative 4, 9. So I just wrote it. And let's find that determinant. Remember, you multiply 3 by 9, subtract negative 4 times 5 from it. That's 27 plus 20, or 47. So that's D. D for determinant. And then what Cramer proposed is this. He came up with D subscript x. The subscript x means this. You keep 4, 9 in D, and we're actually going to throw away that column, the x column. So remember, this x tells you which column to throw out. So we're going to literally throw that out. Now if I throw it out, look, my matrix, the 2 by 2 here, is incomplete, isn't it? I need 2 numbers here. The 2 numbers that go in here are 6, 10. Those constants. Okay, so I'm going to put in 6 and 10 in here. And those are the numbers that will replace. So again, the subscript x tells you which column to discard or throw away. Now once we were done, then we calculate determinant again. 6 times 9 minus 4 by 10. And that's 54 minus 40, that's 14. Okay, and that's dx. And then he proposed to do dy. You can imagine now what dy does. The subscript tells you which column to throw away. Okay, so in fact we're gonna do that. We're gonna throw away, because the subscript is y, we're gonna get rid of that column. Okay, so let me rewrite in D. The first column of D is 3, 5. The second column, gone. What are the 2 numbers that go in there? just like before, for dx, we're going to put 6 and 10 in here. You see that? 6 and 10, and find that determinant. 3 by 10 minus 6 by 5. That's 30 minus 30, right? 3 by 10 minus 30, 0. And there we have it. Now that's not the system, right? We just found 3 determinants. Now this is, again, what do each of these mean? They mean nothing. But here is interestingly how 3 pieces of information that didn't in and of themselves mean anything suddenly going to give us a solution. The solution to x is dx over d, and the solution to y is dy over d. There. Simple, huh? Now dx is 14. D is 47. So the first solution here is 14 47ths. Let me make sure that I copied the problem right. Yeah, I did. So D again is, I just want to review. Anytime I get a fraction, I double check, see if there's something I made a mistake on. So remember, let's recap. dx means you throw away the x column. So D is 3, 5, negative 4, 9. dx is going to be 6, 10, negative 4. Sorry. That's negative 4, right? And that's why that fraction came out the way it did. Okay, but my dy looks right. And dy, that's, you throw away the y column, so that's 3, 5, 6, 10. This looks good. So I just need to reformulate the x, right? So let me correct it. And the only difference is going to be right in here, right? That's going to be a negative 4, which makes it positive 40, 40, and 54, right? 6 times 9, 54. 54 and 40 is 94. So dx is 94. That means I gotta fix this part. Okay, now it looks better. So there's 94 over 47. And y is going to be 0 over d. D is 47. 94, 47 is 2, and 0 over any non-zero is 0. So the solution to this system xy is 2, 0. That's what that is. Okay. And there you have it. Now, with the Cramer's method, and again, the formula, by the way, exists for 3 by 3s, but don't worry about it. We just look at 2 by 2s. Now, this works provided d is not 0. D is the denominator in Cramer's method, right? So usually, if d is 0, well, d is 0, that means division by 0, which is undefined. So in that case, the system either has no solution or the system is a dependent solution. Okay, and we can investigate that further using other methods. Alrighty, so that's all we want to do in this section, section 8.7, the idea of determinants to solve 2 by 2 systems. Hopefully you found this easy to do. It's a very simple method, and of course a short video in this section. Okay, and with that we are done with this section.